Have you ever felt that the universe is playing a quiet joke on our common sense? It is as if the rules we rely on to get through the day are only a thin, warm blanket over a much stranger reality. Welcome to Sleepy Mind Lab. If you find comfort here in the quiet hours of the night, please consider subscribing and sharing this space with others who might enjoy it. Tonight, we are going to explore 70 realities that seem completely impossible, yet are fully verified by science and history. These are beautiful, puzzling pieces of our world that defy our everyday logic, gently nudging us to see things in a new light. So, let yourself settle in, release the tension in your shoulders, take a slow, deep breath, and let us begin our journey together into the unexpected. The temporal illusion of Cleopatra. Let us begin by stepping back to the city of Alexandria, where the warm Mediterranean sea breeze carries the scent of salt and dry papyrus. We find ourselves in the quiet court of Cleopatra, the last active ruler of the Ptolemaic kingdom of Egypt. To many of us, she represents the very dawn of ancient history, standing side by side with the creators of the Great Pyramids in our imagination. We tend to flatten the distant past, grouping all of ancient Egypt into one single, static chapter of human existence. But time is far deeper than our minds naturally grasp. When Cleopatra looked out from her palace windows, the Great Pyramid of Giza was already an ancient relic, weathered by thousands of years of wind and desert sand. In fact, it was built around 2,500 years before her reign. That is a vast stretch of time, longer than the gap that separates us from Cleopatra today. If we measure the timeline, the distance becomes clear. Cleopatra lived around the year 30 before the Common Era. The first human footprint was pressed into the quiet dust of the moon in the year 1969. This means that Cleopatra lived roughly 2,000 years before the Apollo 11 mission. She was closer in time to Neil Armstrong than she was to the laborers who dragged the massive stones to build the Great Pyramid. This realization reveals a beautiful distortion in our mental maps of the past. We squeeze thousands of years of human struggle, invention, and daily life into a single quiet moment. In reality, history is a deep, quiet ocean, and the spaces between our ancestors are much wider than they seem. Our surprising family tree. A bright yellow banana sits quietly on a kitchen table. It is silent, still, and completely unlike us. Think of how quiet and simple it seems, just resting there. It does not speak, it does not move, and it certainly does not look like us. Yet, deep inside its cells, a quiet recipe is being read, written in the exact same biological alphabet that builds your own body. If we compare the genetic code of a human being to that of a banana, we find a surprising overlap. We share about 50% of our genetic material with that simple yellow fruit. This deep connection comes down to the fundamental chores of being alive. Every living cell, whether it belongs to a human or a plant, has to perform the exact same basic work to survive. Cells must divide, repair their walls, replicate their genetic material, and convert nutrients into usable energy. The biological instructions for these everyday tasks are ancient and universal. They were written billions of years ago in a single, microscopic common ancestor that we all share. Over vast stretches of time, life branched out into trees, fish, birds, and people. But we never threw away the original instruction manual. We kept the chapters that tell cells how to breathe and grow. So, the quiet fruit on the counter is actually a distant cousin. We are deeply woven into the fabric of the living world around us, sharing our very blueprint with the trees in the forest and the plants on our windowsills. We are all branches of the exact same family tree, carrying the memory of our shared beginnings. But what happens when we zoom into the strange mathematical rules that govern our everyday social coincidences. The counterintuitive probability of birthdays. Imagine walking into a small, cozy room. Perhaps it is a local coffee shop on a rainy afternoon or a quiet college seminar classroom. You look around and count the people sitting near you. There are only 23 individuals in the room, including yourself. If someone asked you what the chances are that 2 people in this small group share the exact same birthday, you would likely guess it is very small. After all, there are 365 days in a year. It seems like you would need a crowd of hundreds of people to find a matching pair. Yet, if you actually went around the room and asked everyone for their birthday, you would find something highly unexpected. In a room of only 23 people, there is a 50% chance that 2 of them share a birthday. If you add just a few more people, bringing the total to 70, the chance jumps to over 99%. It feels almost like magic, a strange glitch in our everyday logic. To understand why this happens, we have to look at how our brains process groups. When we enter a room, we naturally compare ourselves to everyone else. We think about the odds of someone else sharing our specific birthday. Since there are 365 days, the chance of another person sharing your birthday is indeed very small. But the math of the birthday paradox does not care about you specifically. It cares about any 2 people in the room sharing any birthday. Instead of looking at individuals, we have to look at pairs. With 23 people, we are not making 23 comparisons. We are looking at every possible pairing of people in the room. You compare the first person with 22 others. You compare the second person with 21 others, and you compare the third person with 20 others. When you add all these unique pairings together, 23 people actually create 253 unique pairs. With 253 pairs, the opportunities for a match multiply rapidly. Each pair is a new chance for a shared birthday. When we look at it this way, the high probability starts to make sense. Our human intuition is built for simple, direct relationships. We struggle to naturally calculate the rapid growth of connections in a group. It is a quiet reminder of how reality operates on rules that often bypass our simple instincts. The world is full of these invisible mathematical connections, quietly weaving patterns right before our eyes, even in a quiet room of 23 strangers. The moon drifting away. Imagine standing outside on a quiet, clear summer night. You notice the glowing silver moon, hanging perfectly still in the dark sky. It feels like a permanent, unchanging anchor of our world. But this stillness is a beautiful illusion. Right now, at this very moment, the moon is silently, steadily escaping from us. Every single year, the moon moves about 3.8 centimeters further away from the Earth. To put that into perspective, that is roughly the same speed at which your fingernails grow. It is a tiny, almost imperceptible shift, yet it is happening every second of every day. This cosmic dance is driven by a gentle tug of war between the Earth and the moon. As the moon orbits us, its gravity pulls on our oceans, creating the tides. But the Earth spins much faster than the moon orbits. This rapid spin drags the tidal bulge of the water slightly ahead of the moon. This extra mound of water pulls the moon forward, giving it a tiny boost of energy. This extra energy pushes the moon into a slightly wider, higher orbit, causing it to spiral outward. At the same time, this friction acts like a gentle brake on our planet. The energy transferred to the moon comes directly from the spin of the Earth. As a result, our planet is slowing down. Long ago, when the moon was much closer, a single day on Earth lasted only about 6 hours. Since then, the days have been silently lengthening, adding a fraction of a second every century. Eventually, the days will grow longer and longer. In the deep future, our planet will spin so slowly that a day will last for weeks. the moon will seem to stand completely still in the sky, locked over one side of the Earth, a distant and quiet companion drifting in the dark. Earth has more trees than stars. When we stand outside on a clear night, the sheer number of stars feels infinite. We feel so small compared to the vast Milky Way galaxy. Yet, if we think of the woods and forests of our own world, we find a different kind of infinity. Our green planet is actually richer in trees than our galaxy is in suns. Astronomers estimate there are about 100 billion stars in the Milky Way. That is a massive number of burning suns. But if we count the trees on Earth, the number is much larger. There are about 3 trillion trees growing on our planet. That means for every single star. In the night sky, there are 30 trees right here on the ground. This changes how we see our home. We do not need to search deep space to find limitless abundance. We can walk through a forest and feel that same quiet awe. Every leaf, every branch, and every trunk is part of a giant green galaxy right here under our feet. As you rest tonight, you can feel safe knowing you are surrounded by a planet that is bursting with quiet, rich life. Oxford predates the Aztec Empire. Imagine a damp, chilly morning in the 11th century. Students walk through the narrow, stone-paved streets of a quiet English town named Oxford. They are carrying heavy, handwritten scrolls, rushing to hear a lecture on grammar or logic. The year is 1096. This is the very beginning of the oldest university in the English-speaking world. Now, let us cross the Atlantic Ocean and travel forward in time. We often think of ancient empires as existing in a distant, foggy past, long before modern history began. But the famous Aztec civilization of Mesoamerica did not even begin until the year 1325, when they founded their grand city of Tenochtitlan on a swampy island. This means that by the time the Aztec people were starting to build their empire and design their magnificent temples, teachers at Oxford had already been grading essays and holding exams for more than 200 years. Our minds tend to place history into neat, separate boxes. We put medieval European knights in one box, and we put the massive stone pyramids of the Americas in a completely different, much earlier box. Yet, the grand halls of Oxford are older than the entire rise and fall of the Aztec Empire. It is a strange realization that while English scholars were debating philosophy in stone halls, the famous civilizations of the Americas were still centuries away from their peak. History is not a neat line of events waiting for their turn. It is a messy, overlapping web where the old and the new exist at the very same time. The quantum observer effect. Imagine a quiet room where a simple wooden door remains closed only when you observe it. The moment you turn your back, that door dissolves into a gentle mist, spreading out to exist in every corner of the room, all at the same time. This sounds like a fairy tale, yet in the deepest layers of our physical universe, this is exactly how reality behaves. At the subatomic level, the tiny building blocks of everything we know act like solid billiard balls when we watch them. But the moment we turn our eyes away, they dissolve into a wave of pure possibility, drifting through space in many places at once. To understand how this happens, we can think about a simple experiment. Imagine a wall with 2 narrow vertical slits cut into it, and a screen positioned behind it. If we were to roll tiny tennis balls at this wall, some would bounce off, while others would pass through the 2 slits, forming 2 straight lines on the screen behind. This is what we expect from our everyday experience of solid objects. But if we send tiny pieces of light or matter, like electrons, toward these 2 slits, something strange happens when we leave them alone. Instead of making 2 neat lines, they create a striped pattern of many lines, just like ripples of water overlapping in a calm pond. A single electron seems to travel through both slits at the very same time, interfering with itself like a wave. The mystery deepens when we try to catch the electron in the act of passing through. Scientists placed a tiny detector by the slits to see exactly which opening each electron actually goes through. As soon as that detector was switched on, the electrons stopped behaving like waves. They went back to acting like tiny solid tennis balls, passing through only one slit or the other, leaving only two simple lines on the screen. The act of measuring them, the simple presence of an observer, forced the electron to choose a single physical location. This discovery challenges our deepest assumptions about the world around us. It suggests that a particle does not have a definite place in space until it is observed. When we do not observe, the universe exists in a state of fuzzy potential, a beautiful cloud of possibilities. It is as if the foundation of reality requires some form of observation to fully crystallize into solid existence. The world we touch and feel is not a finished stage waiting for us to walk onto it. Instead, it seems that our very presence as observers plays a role in creating the physical world. If simply observing a particle can change its behavior, what happens when two particles are completely separated by space? Spooky action at a distance. Albert Einstein once called it spooky action at a distance. He did not like it because it seemed to break the most fundamental rule of the universe, the rule that nothing, absolutely nothing, can travel faster than the speed of light. Yet, this strange phenomenon is completely real, and it challenges everything we think we know about how the cosmos is put together. To understand how this works, we can imagine a pair of socks. One sock is bright blue, and the other is warm red. You place each sock into its own identical cardboard box, sealing them tight. You keep one box with you in your quiet room, and you send the other box with an astronaut on a rocket ship journeying to the opposite side of the galaxy, billions of miles away into the cold dark. In our normal, everyday world, the moment you open your box and see a red sock, you immediately know that the astronaut has the blue sock. This is simple logic. The socks were always red and blue from the very moment you packed them. But in the tiny realm of the very small, the quantum realm, nature does not behave this way. At the quantum scale, before you open your box, the sock inside is not red and it is not blue. Instead, it exists in a strange, blurry mixture of both colors at the exact same time. It is a shifting shadow of possibilities. It is only when you lift the lid of your box and look inside that the sock suddenly chooses to become red. And at that exact same split second, billions of miles away, the other sock instantly becomes blue. It does not matter if the boxes are separated by a few inches or by entire galaxies. The change happens instantly, without a single moment of delay. If a physical signal had to travel from your room to the rocket ship to tell the other sock to turn blue, that signal would have to travel millions of times faster than the speed of light. But according to everything we know about physics, that is supposed to be impossible. This phenomenon is known as quantum entanglement. Two particles become so deeply connected that they behave as a single entity, sharing one existence across the vast emptiness of space. They are like two dancers performing the exact same moves in perfect unison on opposite sides of the universe, even when they are separated by a wall of silent stars. This leaves us with a profound realization about our universe. It suggests that space is more than a giant, empty void separating distant objects. Instead, there is a quiet, invisible thread that binds the universe together in a way we are only beginning to comprehend. The separation we see between things might be an illusion. Beneath the surface of our everyday reality, everything is woven into a single, deeply connected tapestry, sharing whispers across the dark. Mammoths and the Great Pyramids. Let us take a quiet journey to a freezing, wind-swept island in the far north of the Arctic Ocean. Silent snow falls on a lonely landscape. A thick coat of dark brown hair shivers in the icy wind. A massive beast, a woolly mammoth, heavy and majestic, slowly walks across the snow. Its curved tusks sweep through the drifts as it searches for dry grass beneath the deep ice. We often think of these ancient giants as creatures from a completely different era, lost to the deep mists of prehistoric time. Yet, a small, lonely population of woolly mammoths survived and lived on Wrangel Island until about 1650 years before the Common Era. Now let us travel thousands of miles south, leaving the ice behind for a warm, sandy desert under a bright, golden sun. Hundreds of workers are hauling giant limestone blocks, building the Great Pyramid of Giza. Stonemasons are carving, pharaohs are ruling, scribes are writing on papyrus, and a complex human society is thriving. We tend to separate these two worlds in our minds. One feels like a cold, primeval dream from a time before humans, while the other feels like the start of modern history. The reality is that these two timelines overlapped. When the great stones of the pyramids were being stacked to touch the sky, woolly mammoths were still breathing, walking, and living their quiet lives on their Arctic island. This means the prehistoric world of giant Ice Age beasts and the dawn of our own recorded history were happening at the exact same time. They were separated by distance, rather than by millions of years, existing together on the very same planet. The distant past is far closer to our own story than we ever realize, joined together by a single tick of the planetary clock. Hot water freezes faster than cold. If you take two identical cups, fill one with warm tap water and the other with water that is already cold, and place them side by side inside a cold freezer, common sense tells us that the cold water should turn to ice first. It already has a big head start. But sometimes, the hot water wins the race to become solid ice. This strange occurrence is known as the Mpama effect. It got its name from a high school student in Tanzania named Erasto Mpemba in 1963. While making ice cream in his school class, he noticed that his hot mixture froze much faster than the cold mixtures of his classmates. When he asked his teacher why this happened, he was told he was simply confused. But he persisted, and eventually, a physics professor helped him prove it to the world. Scientists still debate exactly why this happens. One simple explanation is evaporation. As the hot water sits in the cold air, some of it turns to steam and escapes. With less liquid left in the cup, there is less water to freeze. Another explanation involves how heat moves. In a cup of hot water, the liquid at the top cools down fast and sinks, while warmer water rises. This creates active currents of moving heat, which can cool the liquid down much faster than a cup where the water is already still and cold. Water is the most common liquid on our planet, yet it still holds secrets that puzzle the most brilliant minds. It is a gentle reminder that even the simplest things in our daily lives can defy what we expect. Why you never see yourself blink? Stand in front of a mirror and try to watch your own eyes blink. Focus on your reflection, stare directly into your own pupils, and try to catch the moment your eyelids close and open. No matter how hard you try, you will never see it happen. You can see other people blink, and you can see a recording of yourself blinking. But when you observe your own face in real time, the blink is completely invisible. Every single day, we blink 15 to 20,000 times. If our eyes behaved like simple cameras, we would spend nearly 40 minutes of our waking hours in total darkness, experiencing thousands of tiny, jarring blackouts. Yet, our world remains perfectly smooth, continuous, and steady. We move through our lives completely unaware of the constant interruptions. This happens because your brain is a highly active editor rather than a passive lens recording the world. The moment your eyelids begin to move, your brain sends a signal to suppress the visual input. It temporarily dims the connection between your eyes and your awareness. This neurological process is called saccadic suppression, and it works by actively editing out both the darkness of the closed eyelid and the rapid motion of the eye. Instead of showing you a blank screen, your brain holds onto the last clear image you saw and stretches it across the gap of darkness. When your eyes open again, the brain seamlessly connects the old image to the new one. You live in a beautifully edited movie, where the cuts are so smooth you never even notice they happened, allowing you to experience a seamless reality. It is a quiet, daily magic, a protective design that keeps our minds calm and our perception of the universe beautifully unbroken. The Mercator Map Distortion. Think of a flat paper map pinned to a classroom wall. You have likely seen it hundreds of times, steering your eyes across the wide blue oceans and the colorful shapes of the continents. On this map, Greenland appears huge, stretching out across the top, looking almost the same size as Africa. But this image is a lie told by geometry. To turn a round, three-dimensional planet into a flat, two-dimensional sheet, mapmakers had to make a choice. One common way to do this is by wrapping a sheet of paper around a globe to form a cylinder, and then projecting the features of the Earth onto it. When you unfold that cylinder, you get a flat map, but there is a catch. To keep the directions straight for sailors, this method stretches the top and bottom of the map outwards. The closer you get to the poles, the more the land gets pulled and expanded like warm taffy. Because of this stretching, Greenland looks giant. In reality, Africa is actually 14 times larger than Greenland. You could fit the entire landmass of Greenland inside Africa multiple times, with room left for the United States, China, and India combined. Our minds have grown up with this distorted view of the world, shaping how we think about the size and importance of different countries. It is a quiet reminder of how a simple design choice can quietly bend our understanding of the ground beneath our feet. But maps are not the only things that twist our sense of scale when we try to count the infinite. Some infinities are larger than others. Let us sit quietly for a moment and think about a question that sounds like a riddle. How can one endless thing be bigger than another endless thing? It feels like it should not be true. Infinity is supposed to mean without end, so how could one endless list be longer than another? If you start counting now, 1, 2, 3, and keep going forever, you are walking along an endless path. This is the infinity of the whole numbers. It is a massive, unending line of stepping stones stretching out into the dark. We call this countable infinity. Now, imagine another kind of infinity. Think about the space between the number 0 and the number 1. Within this tiny, quiet gap, there is a whole universe of decimals. There is 0.5, 0.25, 0.25, 0.33, and an endless stream of others. A mathematician named Georg Cantor found a way to compare these two concepts. He wanted to see if we could pair them up, like guests at a dance. If every whole number can hold hands with exactly one decimal, and absolutely no decimal is left out, then these two infinities are the same size. So, you try to make a list. You write down the whole numbers in a vertical line, and next to each one, you pair a decimal. But Cantor showed that no matter how clever you are, and no matter how long your list is, you will always miss some decimals. He showed this with a simple, beautiful thought experiment. Imagine your endless list of decimals. Now, go down the list diagonally. Take the first digit of the first decimal, the second digit of the second decimal, the third digit of the third, and so on. Now, change each of these digits slightly to make a brand new decimal. This new number is very special. It cannot be the first decimal on your list, because the first digit is different. It cannot be the second, because the second digit is different. In fact, it cannot be anywhere on your list, even if your list goes on forever. You have just created a number that slipped through the cracks. Even though your list was infinitely long, you still left numbers out. The infinity of decimals is fundamentally different. The whole numbers are like steps we can count, even if we never reach the end. But the decimals are uncountable. They are like a smooth, unbroken flow of water. There are more numbers between 0 and 1 than there are whole numbers in the entire, endless universe. It is a quiet, comfortable realization. It means that within the smallest pause, within the space of a single second, there is a depth so vast that a larger infinity easily swallows a smaller one. As you rest tonight, let your mind drift into these endless, quiet layers of mathematics. There are infinities within infinities, all resting in the fabric of reality, silent, peaceful, and beautifully endless. Russia is bigger than Pluto. Imagine standing at the very edge of our solar system, looking out into the cold, silent dark. Out there, billions of miles away, floats Pluto. It is a lonely world of ice and frozen mountains, drifting in the quiet of deep space. We grew up thinking of it as a whole planet, a distant destination that feels impossibly huge. Yet, if you could somehow peel the surface off this entire celestial body and lay it flat, it would cover less ground than a single country on our own Earth. The numbers are difficult to believe. The total surface area of Pluto is about 16,600,000 square kilometers. Russia, however, stretches across 17 million square kilometers of our own world. A traveler could cross the snowy plains of Siberia and still not cover the vastness of this single nation, which actually holds more territory than that entire frozen sphere. It makes us realize how small that distant planet really is, and how vast our home feels. We live on a world so grand that its individual countries can easily swallow entire planets whole, leaving us to sleep under a sky that is much larger than we ever imagined. The independent minds of the octopus. Imagine a quiet, moonlit ocean. Deep beneath the surface, a soft-bodied creature slides gracefully through a dark reef. It flows over the sharp edges of rocks and slips into tiny crevices with absolute ease. This is the octopus, an animal that challenges our very understanding of intelligence. We usually think of the mind as a single control center, a brain nestled safely inside the head that makes all the decisions. But for the octopus, the mind is spread out across its entire body. An octopus has 9 brains. While there is a central brain between its eyes, 2/3 of its nerve cells actually live inside its 8 arms. Each individual arm can taste, touch, smell, and move entirely on its own. If an arm is exploring a crack in the rock, it does not need to wait for instructions from the head. It can decide to grab a shell, investigate a texture, or pull back from a threat, all by itself. This decentralized intelligence lets the octopus solve highly complex puzzles. It can open jars, unscrew tight lids, and escape from secure enclosures because its limbs are like 8 independent problem solvers working in perfect harmony. One arm might be busy untying a knot, while another is tasting a shell, and a third is anchoring the body to a rock, all without the main brain ever having to get involved. It is strange to consider what this feels like. Imagine if your hands had their own thoughts, their own memories, and their own curiosity, yet they still belonged to you. The octopus lives in a state of shared awareness, where the body is a tool of the mind, and also the mind itself. It is a beautiful, alien way of being alive, drifting silently through the deep. the dangerous comfort of a crowd. Imagine walking down a busy city sidewalk on a cool autumn evening. The street is filled with people hurrying home, their minds occupied with dinner plans and daily worries. Suddenly, you spot someone collapsed on the concrete just a few steps ahead. The natural assumption is that someone will surely step in to help. With dozens of people around, it feels certain that someone has already called for assistance or knows exactly what to do. But human psychology reveals a quiet and unsettling paradox. When you are in a large crowd, you are statistically far less likely to receive help during an emergency than if you were alone with a single stranger. Researchers call this the bystander effect. It is driven by a deep mental process known as the diffusion of responsibility. When many people are present, the silent obligation to act divides among everyone in the crowd. Each person silently assumes that someone else will take the first step, leaving the responsibility to drift away. We also look to the actions of those around us to define our own reality. If we see others walking past the collapsed person, acting as though nothing is wrong, we assume there is no genuine crisis. The collective silence of the crowd becomes contagious, convincing us that inaction is the correct path. Every individual waits for someone else to show concern, and because everyone is waiting, no one acts. Recognizing this hidden pattern changes how we see our daily interactions. If you ever find yourself in a crowd needing help, the key is to break the collective spell. You must speak directly to one specific person, point at them, and ask them to help you. By doing this, you turn the crowd back into individuals, restoring the natural human connection that keeps us safe. The fax machine before the Civil War. Imagine stepping into an office in the 1980s. You hear the high-pitched screech of a fax machine sending a paper document across the country. We easily associate this technology with the late 20th century. But the ability to send an image down a wire is far older than we realize. In 1843, a Scottish inventor named Alexander Bain patented the very first chemical telegraph. This was decades before the American Civil War began, and years before the telegraph itself became common. The machine did not use digital screens or computer chips. Instead, it used a swinging pendulum. One pendulum would scan a raised metal image, like a coin or a piece of metal type. At the other end of a long wire, another pendulum swung in perfect harmony over a piece of paper soaked in chemicals. When the first pendulum touched the metal, it sent an electric current down the wire. The receiving pendulum released that electricity onto the wet paper, causing a chemical reaction that left a dark stain. Slowly, line by line, the image appeared on the other side of the country. While people were still traveling in wooden wagons and using candles for light, they already had the technology to send a picture across vast distances in minutes. It makes us realize how close our ancestors were to the modern tools we use today. History is rarely a straight line. Sometimes the future arrives long before we are ready to build it. If early technology could quietly send images across wires, how does nature balance the massive weights of the sky? The massive weight of fluffy clouds. A single, fluffy white cumulus cloud drifts lazily across a brilliant blue sky on a warm summer afternoon. It looks as light as a handful of cotton candy, seemingly weightless as it glides on the breeze. But that soft appearance hides a heavy reality. That single cloud actually weighs about 500,000 kilograms, which is more than 1 million pounds. To put that into perspective, that is the same weight as 100 large elephants, or a fleet of 4 fully loaded commercial passenger airplanes. How does something so massive stay suspended above our heads? The secret lies in how the cloud is made. It is not one giant object, but rather billions of tiny water droplets scattered across a massive space. Each individual droplet is so small that it falls very slowly, easily held up by a vast cushion of warm, rising air. The warm air rising from the ground pushes upward, gently keeping the heavy mist afloat. Even though we think of clouds as misty, weightless shapes, they are actually massive reservoirs of water floating high above us. It is a beautiful balance of nature, allowing 1,000,000 pounds of water to sail quietly across the sky like a giant, gentle feather. Why you cannot tickle yourself. Try to tickle the palm of your own hand right now. Drag your fingers across your skin. Nothing happens. It feels like a simple, dull rub. But if someone else does the exact same thing, even if you know it is coming, you will likely flinch and laugh. Your body reacts instantly to their touch, yet remains completely numb to your own. This happens because of a quiet, watchful part of your brain sitting at the back of your head, called the cerebellum. Think of it as a highly skilled personal assistant that manages your daily movements. Every single time you decide to move a muscle, your brain sends two messages. One goes to your hand, telling it to move. The other message goes straight to the cerebellum, warning it about what is about to happen. The cerebellum calculates exactly what that movement will feel like before it even occurs. It knows the temperature of your fingers, the pressure they will apply, and the exact path they will travel. Because your brain already knows the outcome, it simply turns down the volume on that sensory information. It filters out the feeling as unimportant background noise. When someone else reaches out to tickle you, your cerebellum cannot predict the exact timing, pressure, or path of their fingers. There is no warning message sent ahead of time. This sudden, unpredictable touch triggers a minor alarm in your nervous system, causing you to laugh and pull away. This filtering system is a vital shield for our sanity. Without it, you would constantly feel the heavy weight of your own clothes, the loud thud of your own footsteps, and the rub of your own joints. Your brain quietly silences your own touch, so you can remain awake and sensitive to the unpredictable world around you. Trees are made of air. Imagine running your hand along the rough, solid bark of a giant oak tree. Feel the heavy, dense wood beneath your palms. It feels completely anchored to the ground, a massive object made of the very earth it stands upon. We naturally assume that trees grow by eating the soil, sucking up the dirt through their roots to build their thick trunks and heavy branches. If this were true, a giant tree would leave a massive hole in the ground around it. Yet, the soil remains almost completely undisturbed. In reality, a tree is made almost entirely of thin air. Every leaf on that giant oak is a tiny solar-powered catcher. As the wind blows, these leaves pull in carbon dioxide, an invisible gas floating all around us. The tree uses the energy of sunlight to break this gas apart, keeping the carbon and releasing the oxygen back into the breeze. That carbon is the basic building block of the wood. The tree weaves these invisible carbon atoms into long, strong chains, slowly building its own body out of the sky. The roots do drink water and gather a few tiny pinches of minerals from the ground, but these make up only a tiny fraction of the tree's final weight. The rest, the solid, heavy wood that you can touch, is actually made of captured carbon dioxide and water. A forest is a collection of massive solid towers built out of sunlight and breath. Every wooden table, every page of a book, and every giant branch in the woods is actually a cloud of gas that has been gathered up and woven into a solid shape. When we stand near a tree, we are standing next to crystallized air. You are mostly bacteria. Close your eyes and think about what makes you, you. We usually picture ourselves as a single, isolated person. We think of our skin as a neat border, separating our own human body from the rest of the world. But if we look closer, down at the microscopic level, that neat boundary completely disappears. Inside your body right now, a bustling metropolis is thriving. This is your microbiome, a massive hidden collection of tiny living microbes. If we count every single cell inside your body, the math reveals a highly surprising reality. You have about 30 trillion human cells, which carry your unique genetic code. Yet, living alongside them, in your gut, on your skin, and in your mouth, are about 39 trillion bacterial cells. More than half of the cells that make up your physical presence are not actually human at all. They are entirely different, independent organisms. These microscopic residents are not freeloaders. They are active, essential partners in your daily survival. They break down the food you eat, extracting vital nutrients your body could never process on its own. They train your immune system to defend you, helping it recognize friend from enemy. They even produce chemical signals that travel all the way up to your brain, quietly influencing your mood, your cravings, and your emotions. Instead of seeing yourself as a single, solitary individual, it is much more accurate to view yourself as a complex, cooperative ecosystem. You are a walking forest, a living planet hosting trillions of tiny, supportive inhabitants. Every single breath you take is shared with a vast community that works day and night to keep you alive. You are never truly alone, because you are a beautiful, quiet partnership of trillions. Time moves faster on Everest. We tend to think of time as a steady, reliable river. It flows at the exact same pace for everyone, everywhere, carrying us forward from second to second. But this comfortable assumption is not how our universe actually behaves. Time is not a constant. It bends, stretches, and flows at different speeds depending on where you are standing and what is beneath your feet. Over a century ago, Albert Einstein gave us a new way to look at reality. He showed us that space and time are not separate things. Instead, they are woven together into a single, flexible fabric. Heavy objects, like our planet, create a dimple in this fabric. The closer you are to the heavy center of the Earth, the stronger the pull of gravity and the more time slows down. This means that gravity acts like a quiet brake on the passing of time itself. To see this in action, let us imagine two identical, highly precise clocks. We place one clock at sea level, right on a sandy beach where the ocean waves lap against the shore. We carry the second clock all the way to the top of Mount Everest, climbing 8,848 meters into the thin, cold air. At the summit of Mount Everest, you are farther away from the heavy core of the Earth. Because you are farther away, the pull of gravity is slightly weaker than it is down on the beach. And because gravity is weaker up there, the imaginary brake on time is released just a tiny bit. The clock on top of the mountain ticks faster than the clock on the shore. If you were to spend your entire life living on the snowy peak of Everest, while your identical twin lived at the ocean edge, your lives would run at slightly different speeds. By the time you both reached 80 years of age, you would be older than your twin by about a fraction of a millisecond. This difference is microscopic, a tiny heartbeat of time that no human sense could ever detect. Yet, this difference is completely real. When scientists take precise atomic clocks up into the sky or onto high mountains, they measure this exact change. The clocks at high altitudes run faster, exactly as the laws of physics predict. It is a quiet, beautiful truth that time is personal. Every step you take up a flight of stairs, every hill you climb, and every flight you take in an airplane alters the rate at which you age. You are moving into a slightly faster stream of time, separating yourself from the slow, heavy pull of the ground. While time flows faster at the heights of the Earth, how does our planet's deep history compare to the cold reaches of space? Sharks are older than Saturn rings. Imagine a world of complete darkness, cold water, and absolute silence. A creature glides effortlessly through the deep primeval ocean. Its sleek body moves with perfect ancient grace, untouched by the passage of time. This is a shark. We often think of sharks as dangerous, modern predators, but they are actually living time capsules. Their ancestors were swimming through the oceans of Earth roughly 450 million years ago. To put that into perspective, trees did not exist yet. Dinosaurs would not walk the Earth for another 200 million years. Even the continents we know today had not yet drifted into their familiar shapes. Now, let us turn our attention upward, far beyond our atmosphere, to the giant gas planet Saturn. When we think of Saturn, we immediately think of its magnificent glowing rings. They seem like a permanent, ancient crown jewel of our solar system. Yet, these grand rings of ice and rock are actually cosmic newcomers. Scientists estimate that the rings of Saturn formed only 10 to 100 million years ago, likely from the icy remains of an ancient moon that drifted too close and was torn apart by the gravity of the giant planet. For hundreds of millions of years, sharks swam in the dark oceans of Earth under a night sky where Saturn had no rings at all. While those brilliant bands of cosmic ice were still waiting to be born, sharks were already ancient masters of survival. They have survived 5 major mass extinction events, quietly swimming through every global catastrophe that wiped out almost all other life. They are a profound testament to the quiet power of simple, perfect design, enduring long before the jewels of our solar system even existed. The fragile truth of your memories. Think back to a vivid memory from your early childhood. Maybe it is the bright red color of a balloon you lost at a park, or the exact smell of your grandmother's kitchen on a rainy afternoon. You can feel the warmth of that day, and you would swear under oath that it happened exactly as you remember it. But then, you mention it to a family member, and they look at you with confusion. They tell you that you never had a red balloon, or that your grandmother lived in a dry desert state where it rarely rained. You are left holding a memory that is entirely blank on the other side. This happens because our minds are surprisingly easy to rewrite. In famous psychological studies, researchers successfully convinced healthy adults that they had been lost in a shopping mall as a young child. The scientists did this simply by suggesting the event happened and by getting family members to play along. Within a few days, the participants recalled the event clearly, and they filled in the details themselves. They remembered the clothing of the elderly person who helped them, and the cold feeling of panic in their chest. They created a vivid, detailed past out of thin air. This happens because your brain does not work like a video camera. It does not record an event and store it away in a dusty drawer to be pulled out and played back later. Instead, every single time you recall a memory, your brain actively rebuilds it from scratch. It gathers pieces of information from different areas and stitches them back together. During this quick rebuilding process, the memory is highly fragile and open to changes. A suggestion from a friend, a photograph you saw years later, or even your current mood can slip in and edit the past. You save the new edited version back into your mind, believing it is the original. Our personal histories are not carved in stone. They are soft, shifting stories that we rewrite every single day. We carry a library of beautiful, vivid moments, yet we can never be completely sure which pages are real and which ones our minds painted while we were not looking. One single time zone across China. When waking up in the far west of China, stepping outside for breakfast can feel rather surreal. The clocks say 10 in the morning, yet the sun is only just beginning to show itself over the horizon. This happens because the entire nation, which physically spans 5 geographical time zones, operates on one single clock. It is called Beijing Standard Time. Back in 1949, the government decided to unite the vast land under a single hour to help a diverse population feel connected. For millions of residents in Western cities, daily life requires a constant, silent negotiation with the sky. School children begin their classes late in the morning, shops stay open long past midnight, and families eat their dinners under the stars. They live by two clocks at once, balancing official schedules with the natural rhythm of the sun. We often think of time as a solid, natural law of the universe. Yet this vast landscape reminds us that the hours on our wrists are simply shared agreements, imaginary lines we draw over a spinning planet that cares very little about our clocks. The unique order of shuffled cards. Imagine holding a simple, standard deck of 52 playing cards in your hands. It feels familiar, light, and ordinary. You slide the cards out of their cardboard box, feel the textured paper, and begin to shuffle them. Perhaps you perform a simple overhand shuffle, or maybe you split the deck in two and let the cards riffle together, interlacing one by one. To your mind, you are just preparing for a casual game. But in reality, you have just participated in a quiet cosmic event. The exact order of the cards currently resting in your palms has almost certainly never existed before in the entire history of the human race. In fact, it has very likely never existed since the beginning of time itself. This may sound like a grand claim for a cheap deck of paper cards, but the math behind it is staggering and beautiful. When we talk about the number of ways to arrange 52 cards, we are dealing with a mathematical concept called 52 factorial. To find this number, you multiply 52 by 51, then by 50, then by 49, and you keep going all the way down to 1. The result is a number so immensely vast that our minds cannot naturally comprehend it. It is a number with 68 digits. To put this giant number into perspective, let us try a few small thought experiments. Imagine that someone set a timer when the universe first began, roughly 13,800,000,000 years ago. Now imagine that every single second since that very first moment, every person on Earth shuffled a deck of cards 1,000,000 times. Even after all those billions of years of constant shuffling by billions of people, they would have only scratched the absolute surface of the possible combinations. The actual number of arrangements is so large that the entire history of our universe is like a tiny drop of water in a vast, endless ocean. Consider another comparison. If you were to count every single atom that makes up our entire planet Earth, from the deepest iron core to the highest whisper of our atmosphere, you would reach a number that is still far smaller than the number of ways to arrange those 52. In fact, if you gathered 1,000,000 planets just like Earth and counted every single atom on all of them, you would still be nowhere near the total combinations waiting inside your deck. Every single time you thoroughly shuffle a deck of cards, you are creating a unique work of art. You are holding a sequence that has never been seen by any human eye, on any world, at any point in history. When you lay the cards down on a table, you have created a brand new arrangement, born in that very second, destined to never happen again. It is a quiet reminder of how much complexity can hide inside the simplest things we hold in our hands. Hearing the Big Bang on television. Inside a quiet, dark room, an old, forgotten television set stands in the corner. On the screen, a chaotic blizzard of black and white static snow dances aimlessly, accompanied by a soft, rushing hiss that fills the silent space. It looks like broken technology, a simple lack of a broadcast signal. But this fuzzy noise is actually a whisper from the deep past. Nearly 13.8 billion years ago, the universe began in a sudden, unimaginable flash of light and heat. As the cosmos expanded over billions of years, that blinding flash stretched out, cooling down and transforming into faint, invisible microwaves that now fill every corner of space. These waves travel through the darkness, unnoticed and silent, yet they are always present. This relic radiation is always around us, washing over our homes and silently passing through our bodies at this very moment. When a person turned on an old analog television and tuned it to a channel between stations, the antenna on the roof would try to catch a signal. It picked up local broadcasts, stray interference from power lines, and even distant storms. But about 1% of that static snow on the screen was actually this ancient cosmic signal, captured by the metal antenna and translated into sound and light right in the middle of a living room. A person was watching and listening to the very birth of space and time, a direct echo of the creation of the cosmos playing out on a dusty screen. It is a quiet reminder that the deepest secrets of our universe are not always locked away in giant telescopes, but sometimes drift right through our everyday lives. If the beginning of the universe is still whispering to us after all this time, are we also made of the same ancient dust? We are made of stardust. Take a deep breath and rest your hands on your lap. Think about your own body for a moment. The solid weight of your bones, the warm blood moving through your veins, and the steady breath flowing in and out of your lungs. It feels deeply personal, uniquely yours. Yet, the physical pieces that make up who you are have a history that goes back billions of years, deep into the dark, silent spaces of the ancient cosmos. In the very beginning, the universe was a simple place. It was filled almost entirely with only two basic ingredients, hydrogen and helium. These light gases could not build a planet, let alone a living creature. There was no carbon for muscles, no calcium for bones, and no iron to carry oxygen through a beating heart. Every single one of these heavier elements had to be made from scratch. And they were made in the only places hot and intense enough to forge them, the hearts of massive stars. For millions of years, these giant suns squeezed hydrogen atoms together under unimaginable pressure, cooking up the heavier elements one by one. Carbon, nitrogen, oxygen, and iron were slowly built deep inside these stellar furnaces. Eventually, those stars ran out of fuel. They collapsed and exploded in brilliant, violent supernovas, blasting their precious creations out into the cold, empty void. Those scattered ashes drifted through space, eventually gathering into a quiet cloud of dust that formed our sun, our Earth, and ultimately, us. Every cell in your body contains atoms that were once cooked inside a dying star. Every part of your physical body is made of this ancient stardust. We are a way for the cosmos to know itself, a beautiful collection of starlight warming the cold, dark space, resting here tonight. The cold furnace of liquid nitrogen. Think of holding a glass of clear, sparkling liquid and pouring it directly onto a wooden table. Instead of pooling or wetting the surface, it instantly vanishes into thick, rolling clouds of white mist. It skitters across the wood like tiny beads of water on a hot frying pan, disappearing before it can even damp the surface. To us, the room is comfortable, perhaps even a bit cool. But to this liquid, which is nitrogen, our normal room temperature is a raging, blazing furnace. We often think of boiling as something that only happens when things are scorching hot. We associate it with bubbling kettles and steam rising from pots on the stove. But boiling is not about human warmth. It is simply the moment a substance changes from a liquid to a gas. This transition depends entirely on how tightly the molecules cling to one another and the pressure of the air around them. Nitrogen molecules do not want to hold onto each other. They prefer to drift apart as a gas. To force them into a liquid, we have to cool them down to an extreme degree. Nitrogen boils at -196 degrees Celsius, which is nearly 320 degrees below zero on the Fahrenheit scale. When liquid nitrogen touches a room temperature table, it experiences a heat shock far greater than water poured onto red-hot coals. The table feels like a scorching stove to the liquid, causing it to boil instantly and violently. This reminds us that our ideas of hot and cold are entirely personal. We live in a very narrow sliver of the universe, and our senses are tuned only to what keeps us alive. Outside our cozy bubble, the rules of temperature stretch out into extremes where the coldest liquids find a furnace in our everyday comfort. Nintendo and the Ottoman Empire. Think about the bright, flashing screens of modern video games and the name Nintendo. We easily associate this brand with cutting-edge digital technology and childhood living rooms. Now, try to place Nintendo in the timeline of world history. It might surprise you to learn that the company was founded in Kyoto, Japan, all the way back in the year 1889. Back then, they did not make electronics. Instead, a craftsman named Fusajiro Yamauchi hand-painted playing cards made from the bark of mulberry trees. At this exact same moment in history, across the globe, the ancient Ottoman Empire was still actively ruling a vast stretch of the world. We often think of the Ottomans as figures from the deep, distant past, existing only in old paintings of sultans and dusty history books. Yet, that empire did not dissolve until 1922. For over 30 years, Nintendo and the Ottoman Empire existed at the exact same time. These two completely different worlds, one a modern gaming giant in the making, and the other a remnant of the medieval world, shared the same earth. History does not run in neat, separate chapters. It flows in parallel streams that constantly challenge our sense of time. Looking backwards through time. Imagine stepping outside on a clear, cool night and letting your eyes drift slowly upward. You see a tiny, delicate speck of silver shining softly in the deep dark. It feels so close, like a quiet nightlight hanging in the comfortable room of our atmosphere. But that soft glow has traveled across an immense, silent distance to reach your eyes. Light travels faster than anything else in the cosmos, moving at nearly 300,000 kilometers every single second. Even at that speed, space is so vast that the journeys are unimaginably long. We measure these gaps in light years, which is the distance light travels in one full year, about 9 trillion kilometers. The starlight entering your eye tonight left its home a very long time ago. For some stars, the journey took 4 years. For others, it took thousands of years. The beam of light you see began its journey before the ancient pyramids were built. While that light was traveling, entire civilizations rose and fell on our planet. It is entirely possible that some of those brilliant stars have already run out of fuel and collapsed into darkness. They might have died 1,000 years ago. Yet, because the light is still traveling toward us, they still shine brightly in our sky. The night sky is a vast, beautiful museum of cosmic history. Every tiny point of light is a snapshot of another era. When you look up, you are not seeing the universe as it is right now. You are looking directly into the past. You are seeing the ghosts of ancient suns, captured in a quiet, comforting moment of time that has already slipped away. The gold inside the earth. Let us take a quiet moment to consider the ground beneath our feet. We walk across soil, grass, and stone, feeling the solid certainty of the earth. Yet, deep down, far beneath the quiet streets and silent forests, lies a hidden treasury of unimaginable scale. If we could somehow pull all the gold from the center of our planet and spread it evenly across the dry land, it would cover the entire surface of the earth in a shining layer that reaches all the way up to your knees. To understand why this precious metal is trapped so far away from us, we must travel back more than 4 billion years to the very infancy of our world. When the Earth first formed, it was a wild, molten ball of liquid rock and metal, glowing in the darkness of space. In this liquid state, gravity acted as a natural sorting machine. Heavy, dense elements like gold and platinum began to sink downward, slowly drifting toward the center of the planet, while the lighter rocky materials floated to the surface to cool and form the crust we live on today. Today, that gold rests in the core of our Earth, thousands of miles beneath our shoes. The pressures there are so immense that they crush atoms together, creating a silent furnace hotter than the surface of the sun. It is a place of absolute darkness and unimaginable weight, holding 99% of all the gold on our planet. We walk our daily paths, completely unaware of the vast, glowing ocean of wealth drifting directly beneath our quiet steps. But what if the most powerful forces on Earth are not hidden in the core, but are as loud as the sun itself? The unheard roar of the sun. Imagine a quiet afternoon. You are sitting by a window, feeling a beam of warm, golden sunlight spill across your skin. It feels peaceful, gentle, and completely silent. But this soft warmth actually comes from a place of unimaginable chaos. 93 million miles away, the sun is burning. It is not a quiet fire. The sun is a colossal, churning thermonuclear furnace. It is constantly detonating millions of hydrogen bombs every single second. The sheer violence of this process creates sound waves of unbelievable power. If the vast emptiness between us and the sun were filled with air, that sound would travel. By the time the sound waves crossed the vast distance to our planet, they would still hit us with immense force. The sound would reach our ears at over 100 decibels. That is as loud as standing directly next to a roaring chainsaw, or a police siren, or a heavy metal concert. We would have to live our lives surrounded by this relentless, deafening scream, day and night, with no way to turn it down. Fortunately, we step outside into a world of quiet, rustling leaves and gentle rain. We are protected by a beautiful feature of our universe. Sound requires a medium to travel, like air or water, to carry its vibrations. The vacuum of space has no air. It is a vast, empty stretch of nothingness. This void acts as a perfect acoustic shield. It swallows the violent, screaming energy of our star and delivers only its gentle warmth and light to our faces. The silence of space is a quiet guardian, allowing us to enjoy the sun in peaceful, soft stillness. The length of your blood vessels. Let us begin with a tiny red blood vessel, a thread so thin that it makes a single strand of human hair seem thick. This microscopic pathway is just one tiny piece of a massive highway system running through you right now. Inside your body, a vast and intricate network of capillaries, veins, and arteries constantly delivers life to every single cell. Capillary walls are so thin that blood cells must squeeze through them in a single file line, sharing oxygen with the surrounding tissue. As you sit here, your heart works tirelessly to pump blood through these pathways, completing thousands of cycles every day. If you were to gently unravel this entire web from a single adult body and lay it out in one straight line, it would stretch for about 100,000 kilometers. That is long enough to wrap all the way around the Earth 2 times. Every second, your heart pushes life through this immense, hidden highway, reaching the furthest corners of your toes and fingertips. It is a dense and beautiful labyrinth of life, silently folded and packed inside you, keeping you warm and alive while you sleep. The white sun in our sky. Every child who has ever sat down with a box of crayons knows exactly how to draw the sun. We reach for the bright yellow crayon and color a warm circle in the corner of the paper, perhaps adding a few simple rays. It is one of the very first things we learn about the world above us. The sun is a warm, golden ball. Yet, if you were to float far above our home planet, beyond the thin blanket of our air, you would discover that our familiar yellow star is not actually yellow. In the deep silence of outer space, astronauts gaze out into the void and see a brilliant, untinted sphere of pure, glowing white. The golden color we love so much is a beautiful trick played by the air itself. As the sunlight travels through our atmosphere, it runs into molecules of gas in a process scientists call Rayleigh scattering. This process simply means that the light with shorter wavelengths, which are the blues and the violets, bounces off the air molecules in every direction. This scattering is why the sky itself looks blue during the day. Because so much of the blue and violet light is scattered away, the direct light that actually reaches our eyes is missing those cooler tones. Without them, the remaining colors blend together to make the sun look warm and golden. We live our lives looking at the universe through a soft, colored lens. The atmosphere protects us, keeps us warm, and gently colors the cosmos, turning a stark white star into the comforting golden beacon of our childhood drawings. Solid ice flowing like liquid. A towering glacier sits as a massive wall of blue mountain ice, silent, heavy, and seemingly frozen in time. It looks as solid as the stone peaks surrounding it, a permanent monument of the cold. Yet, if we could watch this giant over decades instead of minutes, we would see a very different reality. Underneath that quiet, frozen surface, a slow and powerful change is happening. The weight of all that ice is immense. When hundreds of feet of snow and ice pile up, the pressure at the very bottom becomes giant. Under this extreme weight, the microscopic crystals of ice begin to change. They do not melt into liquid water. Instead, they start to slide and shift past one another. The solid ice begins to behave like a very thick, slow-moving syrup. This slow movement allows the glacier to flow down the mountain, creeping forward inch by inch. As it moves, it acts like a giant, heavy bulldozer, carving out deep valleys and reshaping the solid rock beneath it. It is a slow, unstoppable journey. We often think of the world around us as fixed and unchanging. We perceive mountains and ice as solid, permanent things. But when we look closer, we find that even the hardest things have a hidden fluidity. To our brief human senses, the glacier seems completely still. But in the grand scale of time, it is flowing, moving, and reshaping the Earth. It is a gentle reminder that our universe is always in motion, even in the places that seem most frozen. The vast empty space of atoms. If everything we touch feels solid, why do physicists say matter is mostly empty space? It is a question that sounds like an ancient riddle, yet the answer goes to the very heart of how our universe is constructed. When you rest your hand on a wooden table, or feel the cool weight of a smooth stone in your palm, you are experiencing what seems to be absolute solidity. There is no doubt in your mind that something is there. Yet, if we could zoom in to detect the atoms that make up that stone, we would find a landscape that is almost entirely made of nothing at all. To understand this, let us contemplate the scale of a single atom. In the center of every atom lies the nucleus, a tiny, dense clump of protons and neutrons. Surrounding this nucleus is a cloud of tiny electrons. If you were to blow the nucleus up to the size of a single marble and place it right in the middle of a massive sports stadium, the entire atom would be the size of that stadium. The outer seats of the stadium would represent the boundary where the electrons spin. Everything else in between, the thousands of empty seats, the open air above the field, the entire space of the stadium, is completely empty. That means more than 99.999% of an atom is pure, vacant space. If you were to remove all the empty space from the atoms that make up every human being on Earth, the entire human race could fit inside the space of a single sugar cube. If this is the case, why does the table feel solid when you knock on it? Why does your hand not simply pass right through the empty space of the wood? The reason is not because there is solid physical stuff blocking your way. Instead, it is a dance of forces. The electrons spinning at the outer edges of the atoms in your hand carry a negative electric charge. The electrons in the table also carry a negative electric charge. When you push down, these negative charges push back against each other with immense strength. It is the exact same feeling you get when you try to force two matching magnets together. They resist, hovering apart without ever truly touching. When you touch a surface, you are not touching solid matter. You are feeling the invisible shield of electrostatic repulsion pushing your hand away. This reveals a strange, quiet illusion. The solid world we inhabit, the houses we build, the ground we walk upon, and even our own bodies, are ghostly structures of energy. We are collections of tiny, isolated points of matter, floating in vast, silent voids, held together by invisible forces. If our solid world is mostly empty space, how can something as soft as honey survive unchanged for thousands of years? Honey never spoils in tombs. Imagine stepping into a dark, silent chamber that has been sealed away from the world for thousands of years. The air is heavy with dust and the weight of history. As archaeologists carefully brush away the dirt from a clay pot and lift the lid, they do not find dust or decay. Instead, they find a thick, sticky, golden liquid. It is honey, placed there to accompany a pharaoh into the afterlife. And the most beautiful part of this discovery is that if you dipped a spoon into that jar today, it would taste just as sweet and fresh as it did 3,000 years ago. How can something organic survive the passage of millennia without rotting? The answer lies in the beautiful chemistry of the honey itself. Honey is very low in moisture. It is mostly sugar, which acts like a sponge, drawing out any water from its surroundings. Because of this, any bacteria or mold that lands in the jar quickly loses all its own moisture and cannot survive. On top of that, honey is naturally acidic. When bees make honey, they mix in a special enzyme from their own bodies. This enzyme breaks down and creates hydrogen peroxide, a natural chemical that acts as a shield against tiny organisms. This combination of extreme dryness and acidity creates a perfect barrier. It is a natural preservation system that keeps the golden liquid frozen in time. When you think about it, a jar of honey is a literal time capsule. It holds the sunlight, the flowers, and the work of ancient bees, captured thousands of years ago, waiting, completely unchanged, for us to open it today. Drinking the water of dinosaurs. Pour yourself a clean, cool glass of water. As you take a slow, refreshing sip, let the cold liquid settle. It feels brand new, clean, and pure. But the liquid in your glass has a history that goes back billions of years. Earth does not make new water. The very same water we have today has been cycling through our planet since its birth. It rises into the clouds, falls as rain, and flows into the seas in an endless loop. Every single drop has been recycled millions of times over. This means the water passing through you today once quenched the thirst of ancient giants. A massive dinosaur, standing in a prehistoric swamp 65 million years ago, drank this very same water. It processed it, returned it to the soil, and the earth cleaned it and stored it. When you drink, you share a direct physical link with creatures that walked the earth long before humans existed. We are drinking the past, one sip at a time. The largest living organism on Earth. Walk into a quiet forest in Oregon. You step on damp leaves and you notice a small yellow mushroom pushing up through the dark soil. It looks delicate, small enough to fit in the palm of your hand. But this tiny mushroom is only a tiny tip of a massive secret. Beneath your feet, stretching out through the dark earth, is a single living creature. It is larger than a blue whale. It is larger than the giant redwood trees. This single organism covers nearly 2,400 acres of forest. We call it the humongous fungus. It is a giant network of tiny thread-like structures called mycelium. These threads creep through the dirt, wrapping around tree roots, spreading slowly through the soil. When you see mushrooms scattered across this forest, you are not looking at separate plants. You are looking at the fruit of one giant body, like apples on a single massive tree. These threads are extremely fine, yet they form a web that connects the entire forest floor into one cooperative network. This system allows trees to share water and signals with each other, acting like an underground network. The fungus has been growing for thousands of years, perhaps as many as 8,000 years. It moves silently, eating decaying wood and absorbing nutrients. It challenges how we think about life. We think of ourselves as separate individuals with clear boundaries. But here is a living thing that has no single face, no heart, no eyes, and no clear edge. It is a massive, quiet presence, breathing under the damp pine needles, holding the forest together in one giant, silent embrace. Life does not always exist in neat packages. Sometimes, the largest individual is the forest itself, woven together in the dark. The chaotic dance of the double pendulum. Think of a grandfather clock. Inside, a heavy brass weight swings back and forth, with perfect, soothing regularity. You can close your eyes and know exactly where that weight will be in 5 seconds, or 5 minutes, or even 5 hours. It is the very definition of order. It is predictable, reliable, and governed by simple laws of physics that we mastered centuries ago. But now, let us make one tiny change to this simple machine. Imagine we take that swinging rod, and right at the bottom, where the heavy weight sits, we attach a second joint. From this joint, we hang another swinging rod. Now we have 2 pendulums connected end to end, a simple double pendulum. It looks like a basic toy, a simple mechanical device made of just 2 pieces of metal and 2 hinges. We might expect it to behave with the same predictable, rhythmic swing of the grandfather clock. It does not. Instead, it enters a state of absolute wildness. When we release a double pendulum, it does not rock back and forth in a neat rhythm. It flips, it loops, it hesitates, and then it suddenly lunges forward in a series of loops that seem completely random. It looks alive, dancing to a rhythm that only it can hear. If we trace the path of the very tip of the bottom rod with a light, it draws a complex, chaotic scribble in the air. The motion is so wild that no human and no computer can guess what it will do next. This is the doorway to chaos theory. In a normal system, a small change in how we start leads to a small change in the result. If we push a swing slightly harder, it goes slightly higher. If we roll a ball slightly faster, it goes slightly further. But the double pendulum is extremely sensitive to its starting conditions. If we hold the 2 rods up and let them go, they will trace a specific path. If we bring them back to the top and try to release them from the exact same spot, but our finger slips by even the tiniest fraction of a millimeter, the path will be completely different. Within a few seconds, the second swing will bear absolutely no resemblance to the first swing. A difference so small that we cannot even measure it changes the entire history of the movement. This sensitivity is what makes the double pendulum so mesmerizing. It is a simple physical object, yet it behaves with a level of complexity that feels almost conscious. We live in a universe governed by strict mathematical laws. Every action has an equal and opposite reaction. Gravity pulls with exact precision. Yet, even with these perfect rules, nature allows for complete unpredictability. The double pendulum teaches us that order and chaos are not opposites, but neighbors. A system can be perfectly simple, completely rule-based, and still remain entirely beyond our ability to predict. It is a gentle reminder that even the simplest parts of our world hold secrets that we can never fully foresee. The weight of the entire internet. Hold a single ripe red strawberry in the palm of your hand. It feels light, weighing only about 50 grams. Now, consider the vast, endless expanse of the global internet. Think of every digital book, every video, every song, and every email sent across the globe. Think of every piece of data stored in massive warehouses across the planet. If we gathered the entire active internet together and weighed it, it would weigh no more than that single strawberry. This seems impossible. We think of the digital world as a massive, heavy infrastructure of servers and fiber optic cables. Yet, everything we do online is powered by electrons. These are tiny, invisible particles of electricity that move through silicon chips and copper wires to transmit data. Every time you save a photo or send a text, electrons are pushed around. Although we cannot see them, these electrons are physical objects, and physical objects have mass. Physicists calculated the total weight of all the moving electrons that keep the active internet running at any given moment. They measured the electrical current needed to power the servers, the cables, and the routers worldwide. The total mass of all those billions of flowing electrons adds up to about 50 grams. Every memory, every line of code, and the entire sum of human knowledge flowing across the globe weighs the same as a piece of fruit. The digital universe is light, almost like a ghost in our physical machine. While the digital world weighs almost nothing, how much does our own brain invent to fill the gaps in our physical sight? The blind spot your brain fills. Close one of your eyes right now. With your single open eye, look around the space you are in. Everything probably looks completely whole. You see the walls, the furniture, the soft shadows, all in one smooth, uninterrupted view. But you are actually experiencing a beautifully crafted illusion. Right now, in this very moment, there is a literal hole in your vision. It is a blank space about the size of a coin held at arm's length. Deep inside the back of your eye, there is a specialized wall of light detecting cells. This is your retina, the screen that catches the world. To send the pictures your retina captures to your mind, all the nerve fibers must gather together and exit the eyeball. The spot where they bundle together and leave is like a cable plug. Because this exit point is crowded with nerves, there is no room left for light detectors. This spot is completely blind. If you have a physical hole in your vision, why do you not see a dark patch hovering in the air? Your brain hates incomplete stories. It takes the patterns, colors, and textures from the area immediately surrounding the hole and uses them to guess what should be there. If you look at a blank white wall, your brain paints white over the blind spot. If both eyes are open, the other eye helps fill in the gap. Our minds are constantly inventing parts of our world. Much of what you perceive as a direct live stream of your surroundings is actually an educated guess. We do not observe reality exactly as it exists. We inhabit a highly detailed, real-time simulation constructed by a mind that prefers a seamless lie over an incomplete truth. The aerodynamics of the bumblebee. A heavy, round bumblebee, covered in soft yellow and black velvet, hovers lazily around a drooping purple flower in the quiet dusk. It seems completely at ease, yet for decades, a famous story circulated in the scientific world. According to this old tale, the laws of classical aerodynamics proved that a bumblebee should not be able to fly. Its body was simply too heavy, and its wings were far too small to generate the lift needed to get it off the ground. Under the old equations we used to design passenger airplanes, the math simply did not add up. For a long time, this was a charming paradox. But the issue was not with the bee, it was with our simplified models of flight. Humans designed airplanes with stiff, fixed wings that rely on a smooth, steady flow of air. A bumblebee, however, flies in a completely different way. Instead of flapping up and down like a bird, a bee sweeps its wings back and forth, tilting them with every single stroke. This rapid, twisting motion, occurring over 200 times every second, creates tiny, swirling hurricanes right above the wings. These miniature whirlwinds are called vortices. They create areas of very low pressure that lift the bee upward into the air. By constantly creating and riding these tiny, controlled storms, the bee achieves what once seemed impossible. This elegant solution highlights the brilliant ways nature solves complex mechanical problems. While our greatest engineers spent centuries perfecting rigid, straight wings, the humble bumblebee had already mastered the art of chaotic fluid dynamics, using miniature tornadoes to dance from flower to flower in the quiet afternoon breeze. The bristlecone pines older than Rome. High up in the White Mountains of California, a gnarled, weathered pine tree clings to dry rock under a wide desert sky. Its twisted golden trunk looks like a sculpture, polished by ice and howling winds over thousands of years. This silent survivor is known as Methuselah, a bristlecone pine that has lived for nearly 5,000 years. When the first stone was laid for the Great Pyramids of Egypt, this tree was already drinking the mountain rain. When the Roman Empire rose, fought, and fell, it was already ancient. These trees survive in harsh, dry soil where almost nothing else can grow. They live so slowly, growing just a fraction of an inch each year, which makes their wood extremely dense and hard. This solid wood acts like armor, protecting them from diseases, fungi, and insects. Even after they die, their trunks remain standing for centuries, refusing to decay. Take a slow, deep breath and feel the quiet peace of this ancient forest. In the presence of such silent, steady endurance, the rush of our modern world softly fades away. The coldest place in the cosmos. Imagine a place so cold that even the atoms themselves nearly stop moving. In our minds, we often think of the deep, empty voids of outer space as the ultimate freezing point of the cosmos. Outer space is indeed extremely cold, hovering just about 3 degrees above absolute zero, which is the theoretical limit where all thermal motion ceases. This cosmic chill is a faint echo left over from the birth of our universe, billions of years ago. But if you want to find the absolute coldest spot in the entire known universe, you do not look to the dark spaces between the stars. You actually have to look inside physics laboratories right here on Earth. Using precise lasers and magnetic traps, scientists have cooled clouds of gas down to just a fraction of a billionth of a degree above absolute zero. At these extreme temperatures, the physical world behaves in ways that seem entirely alien. The individual atoms slow down so much that they lose their separate identities. Instead of bouncing around like tiny billiard balls, they overlap and merge together into a single giant superatom. This strange state of matter is known as a Bose-Einstein condensate. In this state, the atoms behave more like a single, quiet wave of water than a collection of individual particles. We have managed to build tiny pockets of stillness that are millions of times colder than the deepest depths of space. In the middle of our warm, bustling planet, we have created the quietest, coldest environments in existence. It is a beautiful reminder that our curiosity can shape conditions far more extreme than anything nature has produced on its own. A day longer than a year. Imagine a world where the morning sun rises so slowly that the entire year passes by before you see it set. On our immediate neighbor in space, Venus, this is the slow reality of everyday life. We are accustomed to our 24-hour cycle, where a single spin of the Earth defines our days and nights, while a journey around the sun defines our seasons. But on this nearby world, the cosmic clocks run at a completely different speed. A single day on Venus, which is the time it takes the planet to spin once on its axis, lasts for 243 Earth days. Yet, this slow-moving planet completes its entire orbit around the Sun in only 225 Earth days. A single day on this world is longer than its entire year. The year passes by in a flash, while a single afternoon seems to stretch on forever. If you could stand on the surface, beneath the thick, heavy carbon dioxide clouds, you would experience an environment of heavy stillness. The atmosphere is so dense that it behaves almost like a deep ocean, dragging against the rocky ground as the planet rotates. Because of this slow, backward spin, the sun rises in the west and sets in the east, taking months to cross the hazy sky. This reminds us that the rhythms we take for granted on Earth are not universal laws. Each planet dances to its own strange time, defying our common sense and expanding our view of the cosmos. It challenges our concept of time itself, showing us that even the length of a day is relative to where you stand. But Venus is not the only celestial body with scales that dwarf our everyday earthly experience. The mind-bending weight of neutron stars. Think about holding a small kitchen spoon made of silver in your hand. Now consider placing a tiny speck of dust, barely visible to the eye, right in the center of that spoon. In our normal world, you would not even feel its weight. But if that tiny speck were made of the material from a dead star, a neutron star, the weight would instantly crush the spoon, your hand, and the floor beneath you. A single teaspoon of this material would weigh about 9 billion tons. That is roughly equal to the weight of 900 Great Pyramids of Giza, or every single car on our planet combined, all packed into a space no larger than a sugar cube. If you tried to lift it, you would be trying to lift a mountain range with one hand. It seems impossible that nature could pack so much substance into such a tiny space. To understand how this happens, we have to travel far out into the deep dark of space, to the final moments of a massive star. When a giant star runs out of fuel, it can no longer support its own weight. The outer layers explode in a violent flash, but the core of the star collapses inward under its own gravity. The gravity is so powerful that it squeezes the very fabric of matter itself. In normal matter, like the chair you are sitting on or the water you drink, there is vast empty space inside every single atom. The electrons orbit far away from the center, leaving a wide open field of nothingness. But in this collapsing star, the gravity is so immense that it crushes the electrons right into the protons, turning them into neutrons. It squeezes all that empty space out of the atoms. It is like taking a giant sports stadium and squeezing it down until it fits inside a single marble. The marble still weighs as much as the entire stadium, but it is now unimaginably small. The atoms are gone, replaced by a solid sea of neutrons pressed so close together that they touch. This is a neutron star. It is a sphere of pure, tightly packed neutrons, spinning rapidly in the cold dark. If you could somehow visit one and stand on its surface, you would feel a pulling force that is 2 billion times stronger than the gravity on Earth. If you dropped a small pebble from just 1 meter high, it would hit the surface at millions of miles per hour, smashing into pure energy. The star is so dense that a single cubic inch of its material has more mass than the entire human population of the planet. Nature has compressed the mass of a giant sun into a ball that could fit easily inside the limits of a small city. It exists at the very edge of what physics allows before matter breaks down completely and becomes a black hole. When we look up at the night sky, we are looking at a universe that finds ways to squeeze entire mountains into the palm of our hand, reminding us of the silent, crushing power waiting in the dark. More stars than grains of sand. Let us begin by imagining a quiet walk along the beach at night. You bend down and scoop up a handful of dry, cool sand. As the tiny grains slip slowly through your fingers, you might try to count them. There are thousands in just one small handful. If we were to calculate every single grain of sand on every beach and desert across our entire planet, the number is mind-boggling. Scientists estimate it is around 7 quintillion 500 quadrillion grains. It is a number so vast, it feels impossible to hold in our minds. Yet, if we look up from that dark beach into the deep ocean of the night sky, we are looking at something far greater. For every single grain of sand on Earth, there are about 10,000 stars shining out in the observable universe. This translates to roughly 70 septillion stars scattered across the cosmos. We are resting on a tiny, beautiful grain of sand in a limitless cosmic ocean. It is a vastness that does not need to feel frightening. Instead, it can feel like a warm, quiet blanket, reminding us that we are a small but perfectly safe part of a magnificent, endless home. The forgotten green of plants. Why are our forests painted green instead of red or blue? Think about a walk through a quiet park or a dense forest on a warm summer evening. Everywhere in the canopy, there is a soft, calming blanket of green leaves. We naturally connect this color with life, growth, and the energy of nature. But if we examine closely how a leaf actually works, we find a strange paradox. The green we perceive is actually the one color that the plant has absolutely no use for. To understand this, we have to think about sunlight. Light from the sun appears white, but it is actually a mixture of every color in the rainbow, from deep violet to hot red. When sunlight falls on a leaf, it meets tiny solar panels inside the cells called chlorophyll. These tiny engines are highly selective. They love the high-energy blue light and the steady red light. Chlorophyll drinks these colors in, using their energy to turn water and carbon dioxide into sweet sugars that feed the tree. But when it comes to green light, the leaf hesitates. Green light is not as efficient for the solar collectors of the plant. Instead of drinking it in, the leaf simply bounces it away. The green light bounces off the surface of the leaf and travels straight into our eyes. This creates a beautiful irony. The lush color that we associate with the vibrance of living things is actually the single color of light that plants reject and cast aside. When we stand in a forest, we are not seeing the colors the plants are keeping to feed themselves. We are seeing their leftovers, the gentle green light they did not want. GPS and the relativity of time. Imagine you are driving down a quiet, empty street late at night, guided only by the soft blue glow of your smartphone screen. A calm, automated voice tells you to turn left in 300 feet. It feels completely ordinary, almost boring. But to make that simple turn happen, your phone is whispering to a network of satellites whizzing through the cold vacuum of space, thousands of miles above your head. To give you the correct directions, those satellites have to account for one of the most mind-bending secrets of our universe: the fact that time does not tick at the same speed for everyone. Time is not a constant, steady river. It stretches and squeezes depending on where you are and how fast you are moving. Up there, high above the clouds, the universe moves a little differently. The satellites that power our global positioning system are traveling extremely fast, circling our planet at several thousand miles per hour. According to the laws of physics discovered by Albert Einstein, when you move very fast, time actually slows down for you. From our perspective on the ground, the clocks inside those speeding satellites should tick slightly slower, losing about 7 microseconds every single day. But there is a second, opposite force at play in the cosmos. The Earth is a heavy planet, and its massive bulk pulls on everything around it. Down here on the surface, we are deep inside this heavy gravitational pull. Up where the satellites orbit, the gravity of our planet is much weaker. Einstein also discovered that gravity bends time itself. The stronger the gravity, the slower time moves. Because the satellites are far away from the heavy pull of the Earth, time actually speeds up for them. This gravitational effect is even stronger than the speed effect, causing the satellite clocks to run faster by about 45 microseconds every day. When we combine these two opposing forces, the satellite clocks end up ticking faster than the clocks on our phones by about 38 microseconds each day. 38 microseconds sounds like a tiny blink of an eye. It seems too small to matter. But radio signals travel at the speed of light, which is extremely fast. If the engineers who built these satellites did not adjust their internal clocks to correct for this time difference, the navigation system would lose its accuracy very quickly. In just one single day, the map on your phone would miscalculate your position by about 7 miles. By the second day, the error would grow to 14 miles, rendering the entire system completely useless. Every time you use your phone to find a local coffee shop or navigate through an unfamiliar city, you are actively using the wildest theories of modern physics. The abstract cosmic equations written on blackboards a century ago are not meant only for textbooks. They are secretly running in the background of our everyday lives, keeping us on track and ensuring we never get lost in the dark. The silent communication of trees. Walk through a quiet, misty woodland early in the morning. The air is cool, the damp soil smells of rich moss, and every tree stands perfectly still. It feels like a silent, peaceful collection of separate individuals, each competing with the others for sunlight and water. Yet, beneath the soft dirt, a hidden network is constantly humming with activity. Trees are actually deeply connected to one another through an underground web of microscopic fungal threads. This vast network acts like a natural internet, linking the roots of different trees across the entire forest floor. Through these hidden pathways, trees share vital resources. An older, stronger tree can send sugar and key nutrients to a struggling young sapling growing in the deep shade, helping it survive and grow. These plants do much more than share food. They also speak to one another in times of danger. If a hungry insect begins eating the leaves of one tree, that tree sends urgent chemical warning signals down through its roots and across the fungal network. The neighboring trees receive this silent distress message. They immediately start producing defensive chemicals in their own leaves, making themselves taste bitter and unappealing before the pests even arrive. This cooperative system changes how we must view the forest. Instead of a harsh battleground of selfish competitors, the woodland functions as a single, giant, cooperative superorganism where trees look after their weak and protect their community. If trees have developed such intricate ways to share information, how has our own body adapted to sense the world? The inverted wiring of human eyes. If a human engineer sat down to design a camera, they would place the light sensors right at the front, facing the incoming light, to capture the clearest possible picture. This seems like common sense. Yet, the human eye, which we often compare to a perfect camera, is built completely backward. The light-sensitive cells of your retina, the rods and cones that allow you to perceive the world, are actually pointing away from the incoming light. They sit at the very back of the eye, buried beneath a dense, messy web of blood vessels and nerve fibers. This means that every single ray of light entering your eye must first travel through a thick layer of biological wiring and blood vessels before it ever reaches the senses. In any normal camera, this setup would block the view, casting a shadow of blood vessels over every picture. A dark web of lines would constantly interfere with your view, similar to a cracked window pane. We do not perceive this web because our brain is constantly performing a silent miracle of digital cleanup. Your brain actively processes the incoming signals, recognizes the static shadows cast by your own blood vessels, and digitally erases them from your conscious awareness. It paints over the blind spots and shadows, presenting you with a seamless, clean, and unblemished image of the world. This backward wiring is a strange evolutionary compromise. It exists because of how our eyes first developed millions of years ago, showing us that nature does not always design for perfection. Instead, it works with what is already there, leaving our brain to do the heavy lifting of tidying up our imperfect view of reality. The true shape of raindrops. Water droplets stream down a window pane. We often draw raindrops with a pointed top and a fat, rounded bottom, like a teardrop. This shape is painted on signs and printed in children's books. But the shape of a falling raindrop is different. When a tiny drop of water first forms in a cloud, it is a perfect little sphere. The force of surface tension pulls the water molecules tightly together, holding them in a neat, round ball. As the drop grows heavier and starts to fall, it meets the air below it. For very small drops, surface tension is strong enough to keep them perfectly round. But as they get larger and fall faster, the upward rush of air begins to push against the bottom of the drop. This air resistance flattens the underside of the water droplet. The top remains rounded by surface tension, while the bottom becomes flat and wide. As it speeds through the sky, the drop takes on the shape of a tiny hamburger bun. If it grows too large, the air pressure pushes so hard against the flat bottom that the bun hollows out and breaks apart into smaller drops. During a heavy rainstorm, millions of tiny hamburger buns are falling from the sky. The silent thermos of space. If you think about the deep empty space between the stars, you probably imagine a place that is freezing cold. It is true that the temperature of deep space is extremely close to absolute zero, which is the coldest temperature possible. So, if space is so cold, why do engineers worry so much about spacecraft overheating? To understand this, we have to look at how warmth actually moves around us. On Earth, heat travels in three ways. First, there is conduction, which is what you feel when you touch a hot metal spoon or hold an ice cube in your hand. Second, there is convection, which happens when warm air rises and cool air sinks, or when water currents move warmth around. Both of these ways require physical contact with matter, like air or water molecules. But in the vacuum of space, there are no molecules to carry that heat away from a spacecraft. There is only the third way, which is radiation. This is when heat escapes as invisible light, called infrared radiation. Because radiation is a very slow way to lose heat, space acts like a giant thermos flask. A thermos keeps your hot drink warm because it has a double wall with a vacuum inside, which stops heat from escaping. Space is the ultimate version of that vacuum. When a spacecraft is bathed in the harsh, unfiltered light of the sun, it absorbs heat rapidly, but it cannot easily get rid of it. Without special radiators and reflective blankets, a ship would slowly bake in its own warmth. The void is not a freezing wind that chills you to the bone. It is a quiet, empty room that traps every single bit of warmth you bring into it. Solving the cube in 20 moves. Have you ever held a scrambled Rubik's Cube in your hands, twisting and turning the colorful plastic squares, feeling entirely lost in the mess? It feels like an endless maze. If you scramble it randomly, it seems like you are moving further and further away from where you started, sinking deeper and deeper into total chaos. The number of ways to scramble this simple toy is hard to fully comprehend. There are 43 quintillion different possible configurations. To understand how massive that number is, imagine if we took a different scrambled cube for every single one of those possibilities. We could cover the entire surface of our planet in a solid, thick blanket of colorful plastic cubes. And that blanket would be 300 layers deep. It feels like an infinite ocean of confusion, a state of disorder that should take thousands of steps to fix. Yet, mathematicians discovered a beautiful secret hidden within this puzzle. They proved that no matter how scrambled the cube gets, every single one of those 43 quintillion combinations is never more than 20 moves away from being perfectly solved. They call this 20-move limit God's number. If an all-knowing mind looked at the most messy, chaotic cube in the universe, it could restore order in 20 quick twists, or even fewer. This reveals a comforting pattern in the universe. Sometimes, when our lives, our minds, or our daily routines feel completely scrambled, we feel like we are light years away from peace. But perhaps we are like that messy plastic toy. Even when the chaos feels overwhelming and the paths to order seem lost, we are actually only a few deliberate turns away from making everything align once again. Quiet and order are always much closer than they seem. Falling through the center of Earth. Let us begin with a thought experiment. Imagine drilling a straight, protected tube from one side of the globe directly through the dark, silent center of the Earth, all the way to the exact opposite side. If you were to step into this deep, hollow path, gravity would immediately pull you downward, accelerating your body faster and faster toward the core of our planet. You would feel the rush of wind as your speed increases, falling deeper into the quiet dark. At first, you would experience a brief moment of weightlessness, but soon the sheer scale of the fall becomes clear. As you plunge deeper, you would feel the weight of the world shifting around you. For the first half of your journey, gravity is pulling you toward the hot, dense center, making you move faster with every passing second. You would reach a maximum speed of nearly 18,000 miles per hour at the very center. But once you pass that exact midpoint, a strange transition occurs. Now, all the mass of the planet is behind you. Gravity begins to pull you backward, acting as a natural brake that gradually slows your descent as you rise toward the opposite surface. It acts like an invisible hand, gently catching you as you go. If we ignore the friction of air resistance, this entire journey from one side of the globe to the other would take exactly 42 minutes. At the very moment you reach the other side, your speed would slow to zero, allowing you to simply step out onto the surface of a new hemisphere. This concept is even more extraordinary than it first appears. This exact travel time of 42 minutes applies to a straight tunnel drilled between any 2 points on Earth, whether or not the path goes through the center. If you were to dig a tube from London to Tokyo, or from New York to Sydney, a train powered solely by gravity would take 42 minutes to complete the trip. The steepness of the path balances perfectly with the distance traveled, a beautiful mathematical harmony built into the shape of our home. Even if the tunnel is relatively short, the gravity is weaker, keeping the travel time identical. Imagine the feeling of this silent, weightless journey. For 42 minutes, you would float in peaceful suspension, carried along by the quiet pull of the planet, suspended in a pocket of air as the world slips past. It is a comforting reminder of the hidden rhythms that shape our physical world. If gravity can pull us through the solid Earth, what secrets does simple frozen water hold deep in its structure? The hidden structures of ice. Imagine a cold winter night. A single, delicate, six-sided snowflake lands softly on the dark sleeve of your coat. It is a tiny, perfect crystal, beautiful and fleeting. We look at this speck of frozen water and feel we know exactly what ice is. It is cold, it is hard, and it melts when it gets warm. But this familiar substance holds deep secrets. The ice you drop into a glass of water on a warm afternoon is only one specific version of frozen water. Scientists call it Ice One. It is the only type of ice that naturally forms on the surface of our planet because of our gentle atmosphere. If we travel deep into the universe or plunge far beneath the surface of giant icy worlds, water behaves in ways that seem entirely impossible. Under extreme pressure, the simple molecules of water are forced to pack together in completely different arrangements. Scientists have discovered at least 19 different structures of ice. On planets like Neptune or Uranus, deep under the crushing weight of massive atmospheres, there are vast oceans of hot ice. This is not the cold, refreshing ice from your freezer. It is a solid material that remains frozen even when it is hotter than the surface of the sun. The intense pressure squeezes the oxygen atoms into a rigid cage, while the hydrogen atoms flow through them like a liquid. It is a strange, burning solid that defies our daily experience. It is quiet, comforting, and strange to think about. The very same water we drink and wash with can transform into 19 different structures, each with its own secret patterns, waiting in the dark corners of the universe. The heavy weight of invisible air. Take a slow, deep breath of the invisible air around you. It feels like nothing at all. We move through it so easily that it is easy to forget it is even there. But the air is far from empty space. It is a physical substance made of countless tiny molecules, and it has actual weight. Because of gravity, all of those molecules are constantly being pulled down toward the surface of the Earth. If you could gather up all the air in a typical medium-sized bedroom and put it on a scale, you would probably be surprised by the result. That invisible air weighs about 100 pounds. That is roughly the same weight as a heavy suitcase packed for a long journey or a large dog. Right now, that massive weight is resting inside the room with you, pressing down on every surface, including your own body. This brings us to a beautiful realization. We are currently living at the very bottom of a deep, heavy ocean of air. Every single square inch of your skin is constantly feeling the pressure of about 14.7 pounds of atmosphere. That is equivalent to having a small bowling ball resting on the tip of your thumb. You do not feel crushed by this immense weight because your body is beautifully designed to exist here. The fluids and gases inside you press outward with the exact same force that the atmosphere presses inward. You are in perfect balance with the world around you. As you sink deeper into your bed tonight, let yourself feel supported by this invisible, heavy ocean, holding you gently in place. The oldest recorded joke in history. Imagine holding a small, dusty clay tablet baked in the sun nearly 4,000 years ago in ancient Sumer. It is covered in tiny, wedge-shaped cuneiform writing, a script we often associate with serious laws, royal decrees, or temple records. Yet when researchers translated this specific tablet, dating back to 1900 years before the Common Era, they did not find a solemn prayer or a kingly boast. Instead, they discovered the oldest recorded joke in human history. The joke is surprisingly simple, playing on a bit of universal, everyday embarrassment. It states that since time immemorial, a young woman has never sat on her husband's lap without passing gas. We often think of ancient peoples as distant, stoic figures, living lives entirely different from our own. We think of them only through stone carvings or solemn museum exhibits. Yet, this tiny tablet reveals a shared humanity. Across thousands of years, across vanished empires and forgotten languages, the basic themes that make us chuckle have remained exactly the same. Laughter connects us directly to a person who lived 4 millennia ago, sitting in the warm evening air, giggling at the very same silly human realities we do today. Light slowing down in glass. A single beam of pure white light travels through the cold void of outer space. It moves at the absolute speed limit of the universe, covering 186,000 miles in a single second. It seems completely unstoppable. Yet, when that same beam of light encounters a simple glass prism on a table, it does something beautiful. It bends, splitting into a quiet rainbow of colors. This bending happens because the light is actually slowing down. We often hear that the speed of light is a constant, and that is true when light travels through a perfect vacuum. But when light enters a transparent material like water or glass, it is no longer traveling through empty space. Instead, it must navigate a dense forest of atoms. As the light wave passes through the glass, it bumps into the atoms along its path. Each atom absorbs the energy of the light for a brief, tiny fraction of a second before releasing it again to travel to the next atom. Think of it like a runner trying to sprint through a crowded room. Even if the runner moves at full speed between people, they must constantly slow down to dodge and weave. These microscopic delays add up quickly. By the time the light emerges from the other side of a standard window pane, its overall speed has been cut by about 30%. It is peaceful to think about this gentle drag. The fastest, most energetic force in the cosmos, which can cross the solar system in a matter of hours, is humbled and slowed down by a simple pane of glass. It reminds us that even the absolute laws of the universe can bend and soften when they touch the physical stuff of our world. The infinite length of a coastline. Consider a rugged beach where the cold ocean meets the rocky shore. If you wanted to measure the entire boundary of this country, you might start with a map and a very long ruler. Let us say your ruler is 1 mile long. You lay it down, end to end, tracing the general curve of the land. It gives you a number, but a 1 mile ruler is clumsy. It cuts across small bays, skips over rocky points, and misses the quiet inlets where the water pools. So, you decide to get a smaller ruler, perhaps one that is only 1 foot long. You start walking the beach again, carefully placing the smaller ruler into every little curve, around every jagged boulder, and into every tiny cove. When you add up all these smaller measurements, you discover something strange. The length of the coastline has grown. It is much longer than the first measurement you took from the map. This strange happening is called the coastline paradox. It introduces us to a beautiful branch of mathematics known as fractal geometry. Fractals are shapes that look detailed no matter how close you get to them. A coastline is a natural fractal. It does not have a smooth, neat edge like a triangle or a circle drawn on a piece of paper. Instead, it is a jagged, organic shape that reveals more detail the closer you look. Suppose you shrink your ruler even more. You use a tiny pocket ruler that is only 1 inch long. Now, you must measure around every individual stone, every bump on the rocks, and every small ridge in the wet sand. The total distance stretches even further. If you go down to the scale of a single millimeter, you are measuring around the edges of tiny pebbles. If you go down to the scale of molecules, you are measuring around individual grains of sand. The smaller your ruler becomes, the longer the coastline gets. If you could measure with infinitely small tools, tracing the edge of every single grain of sand and every microscopic atom, the length of the shore would stretch out to infinity. A country with a map that looks quite small can have a border that is mathematically endless. We often think of the physical world as a collection of fixed, simple numbers. We like to believe that a mountain has an exact height, or that a country has a definite, unchangeable edge. Yet, The shape of the Earth resists these simple boxes. It reminds us that some everyday things cannot be neatly captured by a single number. The boundary between the land and the sea is far from a fixed line, winding instead into an endless journey that changes depending on how closely you choose to look. In this way, a single quiet beach holds a vast, infinite world within its shores. The subtle bias of a coin toss. Think of holding a cold, shiny silver coin between your thumb and forefinger. You flick your wrist, sending it spinning up into the quiet air, catching it flat against the back of your hand. For centuries, we have used this simple gesture to settle arguments, make hard choices, and represent absolute 50-50 chaos. We believe that the universe hands us a perfect, unbiased chance. Yet, the physical world has a quiet way of turning our symbols of random luck into predictable science. A team of mathematicians from Stanford University decided to study this exact moment. They recorded tens of thousands of coin tosses with high-speed cameras to see what actually happens while the metal spins through the air. What they discovered defies our common sense. A tossed coin is not actually a 50-50 bet. Instead, there is a tiny hidden bias. The coin is slightly more likely to land on the exact same side that was facing up before you flipped it. This happens because of a subtle wobble in the air, a movement physicists call precession. As the coin spins, it does not just flip perfectly end over end. It wobbles slightly, like a dying top. Because of this gentle wobble, the side that starts facing upward spends a fraction more time facing upward during the flight. The difference is small, about 51% to 49%, but it reveals a comforting reality. What we call luck is often just physics in disguise. The coin does not choose a side. It simply follows the gentle, predictable laws of motion, gravity, and the air around us, carrying a tiny memory of where it began. The giant tongue of the blue whale. Imagine drifting in the deep ocean, watching a massive, dark blue shadow glide silently through the cool water. This is the blue whale, the largest creature to ever exist on our planet, even bigger than the grandest dinosaurs. Everything about this animal challenges our sense of scale. Consider the tongue of this gentle giant. By itself, a blue whale tongue weighs about 2.7 tons. That is over 5,000 pounds of solid muscle. To help us understand this size, we can compare it to the largest animal walking on dry land today. An entire adult African elephant could stand comfortably right on top of that tongue. The tongue alone weighs as much as a fully grown female elephant. It is hard to wrap our minds around a mouth so vast, yet this giant feeds on tiny, shrimp-like creatures called krill, filtering them through huge plates in its jaw. There are giants sharing our blue planet right now, swimming quietly in the dark depths while we sleep. It is a comforting thought, knowing that such quiet, enormous life exists just beneath the surface of the waves. Matches were invented after the lighter. Let us travel back in time to the chilly autumn of the year 1823. In this year, a German chemist created the very first portable lighter, known as the Doberiner lamp. It was a beautiful, complex device. It worked by passing highly flammable hydrogen gas over a piece of warm platinum metal, causing it to burst into a gentle, warm flame. People could suddenly carry fire in their pockets or keep it ready on their desks, using a sophisticated chemical reaction. Now, contrast this with the humble friction match that we all know today. We might naturally assume that the simple wooden match came first, but it was actually invented 3 years later, in the year 1826. A chemist named John Walker accidentally discovered it when he scraped a wooden stick coated in chemicals across his stone hearth, creating a sudden spark of light. The early lighters were much more complex than these simple matches. They relied on delicate chemical interactions, pressurized gas, and expensive metals to function safely. Yet, they arrived on the scene first. It is easy to believe that human progress moves in a straight line from the simplest ideas to the most complicated ones. But history often takes winding paths. The simple wooden match, which relies on a basic scrape of physical friction, took longer for us to conceive than a miniature gas factory inside a glass container. Sometimes the most straightforward solutions are the hardest for us to find, waiting quietly in the background while we build complex machines to solve our everyday needs. The cold desert of Antarctica. Think of a place where a vast, frozen landscape of white ice stretches out to the horizon. Every direction you look, there is only brilliant, blinding white and a stillness that feels almost ancient. It seems like the very opposite of a desert. We usually think of deserts as rolling hills of hot sand, baking under a relentless sun. But science defines a desert by moisture, not temperature. To be a desert, a place simply needs to receive less than 10 inches of precipitation each year. By this definition, Antarctica is a desert, and it is the largest and driest desert on our planet. The air in this frozen world is so extremely cold that it cannot hold water vapor. Because the air is so dry, it is almost impossible for clouds to form, let alone produce snow or rain. Some valleys in Antarctica have not seen a single drop of water or a flurry of snow in millions of years. The massive ice sheets that cover the land are actually ancient, built up very slowly over vast periods of time. Every tiny snowflake that does fall is locked away instantly, never melting. This cold expanse invites us to reflect on how easily our everyday words can mislead us. We create labels like desert and think of heat, yet the absolute driest place on Earth is made entirely of water, frozen solid. Nature does not conform to the simple boxes we build for it. When we let go of our assumptions, we begin to see the world as it truly is, a place of quiet wonders where ice and desert are one and the same. The ghostly feelings of phantom limbs. Wiggle your fingers right now. You feel them move instantly, a quiet confirmation that your hand is exactly where you think it is. But this simple awareness does not actually come from your fingers themselves. It comes from a deeply detailed map drawn inside your brain. Even if a person loses an arm or a leg to surgery, that internal map does not simply fade away. The mind still carries the blueprint of the missing limb, sometimes for decades. This creates a strange experience known as a phantom limb, where a person can feel a missing hand clenching, or an absent foot itching, or even feel intense pain in a space where there is nothing but empty air. It can be deeply unsettling to feel a hand that is no longer there clench into a tight, painful fist, with no physical way to open it. To ease this pain, scientists created a simple and beautiful tool called a mirror box. A person places their intact hand in front of a mirror, hiding the space where the missing hand used to be. By watching the reflection of their healthy hand and moving it, they trick their brain into believing the missing hand has suddenly returned and is moving freely. As the brain watches the reflected hand open and relax, the phantom fist finally unclenches, and the phantom pain fades away. This tells us something profound about our daily lives. The physical world we feel around us is not a direct recording of reality. Instead, it is a complex projection created entirely inside the darkness of our minds, a vivid dream that our brain weaves to help us navigate the dark. The speed of gravity across space. Imagine, for a moment, that the sun suddenly vanishes from the center of our solar system. In a single instant, the giant star that holds our entire cosmic neighborhood together simply ceases to exist. It is natural to think that the Earth would immediately fly off into the dark, cold void of space, cast adrift the very millisecond the sun disappeared. But that is not what happens. Instead, our planet would continue to orbit peacefully, circling an empty, silent patch of nothingness, as if the sun were still shining brightly in the sky. This quiet journey would go on for exactly 8 minutes and 20 seconds. For over 8 minutes, we would remain warm, bathed in sunlight, riding an invisible curve around a ghost star that no longer exists. This happens because gravity does not act instantly. For a very long time, scientists believed that gravity was an instantaneous force, a cosmic thread connecting two objects across any distance in 0 seconds. If you moved one object, the other would feel it immediately, even if they were on opposite sides of the cosmos. But we now understand that the universe has a strict speed limit. Nothing, not even the pull of gravity, can travel faster than the speed of light. The speed of light is about 186,000 miles per second. When the sun disappears, the news of its absence has to travel to us. The gravitational grip of the sun is like a massive blanket that has been stretched out, creating a deep well in the fabric of space. When the sun vanishes, that well flattens out, sending a ripple through the fabric of space. This ripple is a gravitational wave, and it rushes toward us at the exact speed of light. So, for 8 minutes and 20 seconds, the ripple travels across the 93 million miles of dark space, separating us from the sun. During this time, the Earth has no idea the sun is gone. We continue to feel the warm light on our skin. We continue to sweep along our familiar orbital path. Then, at the exact same moment, the last rays of sunlight reach our eyes, and the gravitational ripple finally passes over us. Only then does the sky go completely dark, and only then does the Earth break free, sailing out into the deep night of the galaxy. This cosmic speed limit is a beautiful, orderly safeguard. It prevents our universe from descending into instant chaos. If gravity could act instantly, every minor shift in the distant cosmos would rattle our planet without warning, shaking our orbit before we could even see what was happening. Instead, the universe moves with a patient, measured rhythm. Information and force travel hand in hand, protected by a gentle limit that keeps the cosmos stable, predictable, and quiet. The fragile reality of human perception. Think about the quiet room around you right now. The air feels still, the walls seem solid, and the passage of time feels steady and predictable. It is a comfortable space, designed perfectly for a human being to live, breathe, and feel safe. But as we have explored tonight, this familiar world is only a tiny slice of a much stranger reality. Our senses did not evolve to see the vast cosmic dance, the strange behavior of tiny particles, or the deep history written in the earth. Instead, our brains construct a simplified version of the universe, a helpful shortcut that keeps us safe and focused on daily survival. These 70 truths we have shared tonight remind us that the world is far richer and more mysterious than our eyes and ears can ever tell us. It can feel unsettling to realize how much of reality is hidden from our view. Yet, we can choose to welcome this feeling. This gentle confusion is actually a gateway to wonder. It allows us to step outside our small daily worries and appreciate the beautiful, complex universe we belong to. We do not need to understand every single mystery tonight. We only need to let go, trust the quiet rhythm of our breathing, and allow our minds to rest. Let the weight of the day fade away now. You are safe, you are warm, and you are part of a wonderful, quiet universe. Sleep deeply, and may your dreams be filled with peace.